as is the necessary beginning to these sessions. And then we can get started. The slide I'm going to show you now, I will eventually get to the beginning of the presentation where it's most useful, the introductions. But I just thought I'd put this up. You can get it from the recordings. These are all my contact details. Specifically the email. If you would like at any time to send me an email with questions or comments or insults, if you feel comfortable with that, I don't mind, which I can then work into the presentation or answer the questions or whatever it is. Please feel free to do that. It would help me a lot if I could get input via other means as well. So there are the details, and you can use them as you feel necessary. Oh, okay, will do. Right, I'm going to move on from that. And I'm just going to start quickly right at the very beginning of the normalization of the data. Because it's probably sits there as the basis on which we build our modernization processes. By the way, I'm just giving you a warning. There does seem to be a thunderstorm around at the moment. It's not threatening, but it may or may not cause us to have to cut off at some point in time. So I'm going to quickly go through the normalization, first normal form, to reinforce that, because this is the basis of normalization completely. And it needs to be understood. In order to create a DB2 normalized relational database, these are the 5 criteria that need to be in place in order to start a normalization process. And that means, in summary, okay, there were some examples that we went through. I'm not going to spend too much time on these. I want to get to the summary of the first normal form, which was where we ended on last Thursday. Each physical file table must have a unique key, and a record row may not contain recurring values. These are 2 extremely important philosophies, principles, rules, whatever you like to call them, because these 2 are the basis on which a properly normalized relational database sits. If you think about the unique key concept, if a record exists in a table file and it has a key, it has a set of identifying elements. That key does not necessarily have to be a single element. It can be made up of more than one. A composite key is what we call that, where a key itself that identifies the uniqueness of the record is made up of multiple fields, a composite key or a single field key. If you cannot rely on that being totally unique within the table, if you throw your mind back to the 12 rules of COD, you've got to be able to access the record in a file. You've got to be able to access information primarily by its key. And therefore, if the identifying key for a record in a file, and I will translate that row in a table, if that key is not unique, you essentially have two records or more that can satisfy a request for that key, which means there is no way you can tell which of the multiple records that you can retrieve under those circumstances is the one you want, which is the whole driving principle behind the fact that each record in the table must have a unique key. Now, at the last count, and I can't remember, it's probably gone up by now, but at the last count, the unique key for a physical file stroke record could be a maximum of 2,000 characters. Every time I do this, they've brought out a new version and the option is bigger. But 2,000 was the last one I remember. That is a massive key and far too big to create sensible uniqueness out of it. But that's a limit of the operating system. The record row may not contain recurring values is also exactly the same philosophy. If you have elements in a record that have recurring values, you essentially have multiple values for the same key, which means that you have a non-unique scenario. And when you're trying to relate records together and access information accurately and directly, any situation which generates multiple solutions for any request doesn't work. And that's why I've come back again to reinforce these two basic principles. That every file that you have in your database must contain records of a certain type, containing certain data elements, and they must be identified as unique keys, as uniques. Without that, one cannot begin to go forward. So it is an underlying principle, and probably, if I'm not mistaken, for those of you who have thought about your existing applications, it may be quite a, oops, I was wrong. That thunder is getting closer. It might be quite a disturbing factor. To think that you may have many files in your database that do not have unique keys and you need to find them. And this could mean a massive modification to your database, depending on how, or depending on where you are at this point in time. Now, our approach to this possible, what looks like a disastrous situation, is to take it very slowly, one step at a time, one table at a time, and gradually begin to create the uniqueness. AO has tools that will help you to find uniqueness. But in the end, you're going to have to decide for yourself. This might mean splitting tables. It might allow you to combine tables. And every time you do something like that, your applications are going to need some change. So although it's a core principle and needs attention, if it's done carefully and slowly, the benefits are enormous. Okay, I'm now going to move on to the second normal form. Originally defined by Edgar F in 1971 while he was working for IBM. he is basically, with a couple of others, basically the father of relational databases. And his definition of second normal form, when you take all the theoretical out of it and consolidate it, looks like this. A table that is in first normal form must meet one additional criteria if it's to qualify for second normal form. And that criteria is if and only if all its non-prime attributes are functionally dependent on the whole of every candidate key. Now again, a little translation may not go amiss here. This is the way it's phrased, and if we identify non-prime attributes as being fields that do not form part of the key, and a candidate key is a key that can either be made up of one or more fields. They are prime fields, they are candidate key fields. So what this is saying, a non-prime attribute is one that does not belong to any candidate key. Note that when a first normal form table has no composite candidate keys, i.e., candidate keys consisting of one or more candidate keys consisting of more than one attribute, the table is automatically second normal form, because first normal form has provided uniqueness for the non-prime attributes. And if the table has no composite keys, i.e. it has a single field as a key, the table is automatically second normal form. It must be. So what the second normal form requires is that all fields that are identified by this unique key are functionally dependent on the key. I.e., you don't have a field sitting around in the key that's actually dependent on another key or part of the key. If you have two fields in a key and your element is dependent on only one field in that key, that's not second normal form. It's got to be dependent on the whole candidate key, i.e. all parts of it, in order to be a second normal form. I haven't got into this particular session very far, and I'm beginning to get lightning. Marinus, what do you think we should do here? Should I press on as hard as I can and hope for the best? All right, okay. Marina says I should see how far I can go. The first loud crack of lightning is going to put an end to it, I'm afraid. This is Africa, and we're 6,000 feet above sea level here, and we do get some spectacular storms going past. But let's try at least get through normalization theory, and then maybe we can try again a bit later. Third normal form. Taking a second normal form to a third normal form, which is the form of normalization that is generally used for most relational databases. It combines the requirements of a good relational database with and the flexibility of a database without the overhead of processing normal forms at a higher level or a lower level. So this is usually where we try to get to when we start building our relational database. Let's have a look. Generally, the normal form used in database normalization. Again, Edgar F in 1971 took his second normal form definition and he expanded it to third normal form in order to increase the balance or get a better balance between the flexibility and performance of development for the development of application. Because this is the key, as I'm sure you're all aware, when you are building applications, there is a trade-off in the way you code and what you code for between what is easy to code as opposed to performance when it is being used. We try and balance those two. And third normal form is generally where we try to get to. Right. His definition, Codd's definition, states that a table is in third normal form if and only if both of the following conditions hold true. The first is that the table must be in second normal form. Now, you may think that a bit funny, but there are circumstances where people can claim that they've got a third normal form table that is not second normal form, in which case it's not a third normal form table. It must be truly second normal form before we can even consider the third normal form. And then, in this particular case, every non-prime attribute of T, which is the record or the table, non-prime being those elements that are not part of the candidate key, the unique key, is non-transitively dependent, i.e., directly dependent on every candidate key. Now, this is a very subtle variation or upgrade from second normal form. It's saying that the attributes must be completely directly dependent on the entire key, not just part of it. Second normal form allows you to have fields that are only dependent on part of the key. Third normal form specifically says your non-prime attributes or elements, your data elements, must be dependent on the whole key of the record. So second normal form says they must be dependent on the key, but doesn't imply that they cannot be dependent on some other key as well. Whereas third normal form says that your non-prime attributes must be totally and directly dependent on every candidate key and on no other key. These are a little bit subtle, but once you begin to start organizing your data with these particular parameters in mind, you will actually find that it becomes easier and easier to identify how these things are supposed to fit together. And we will, as we go forward, we will talk about this a lot. I'll discuss, we will build a little application. And we will see, I will talk about what is and what isn't second, third, and so on normal form. There are actually 6 normal forms that have already been defined. What happens as you go through 4th, 5th, and 6th normal form is that you get fewer fields or attributes in a file until at 6th normal form you have 2 fields. One's a key, the other's a data element. This offers the ultimate inflexibility, but it is the worst possible performer because you have so many files and you have to collect and join so much data to make any sense out of it. So generally, I don't discuss anything beyond 3rd normal form because they are theoretical states more than practical states. Okay. Let's just look at a summary. This, I'm simplifying the normalization philosophy down to its absolute essence. Because I find that the theory, as you read it in the books and study it at university and look it up on the Google and so on and so forth, carries so much unnecessary information. So what I've done is I've squeezed out the essence of it. And I've tried to come up with something which is easy to remember, an aid to applying the philosophies, and to give you a handle, something you can work with. So the first thing is requiring the existence of the key ensures that the table is in first normal form, i.e. a unique key must exist in the file that ensures there are no duplicate records in that file based on that key. That key can be made up of 1 or more elements, but that key must define uniqueness. That's the first normal form minimum requirement. Requiring that the non-key attributes be dependent on the whole key ensures second normal form, i.e. all your fields that are not part of the key must be dependent on the whole key and not just on part of the key. Of course, if the table has only 1 element in its key, then first normal form is equivalent to second normal form by definition. The third element is that the non-key attributes must not be dependent on anything else but the key, i.e. dependent on nothing but the key. When you get that situation, you have third normal form. So as you can see from those 3 statements, the key on the file is critical to the entire definition of third normal form. If the attributes are dependent on the whole key, it's second normal form. If they're dependent on nothing else but the key, they're third normal form. And put in that way, in that sense, it's not actually difficult to look at your data and actually tick off the 3 boxes. And of course, I turn that into a motto: the key, the whole key, and nothing but the key. And if you want to take that as an oath, you put it in the end of it, so help me God, because he was the man that designed this philosophy. But this takes the entire normalization process down to a single, easy-to-remember statement that defines third normal form. The key, the whole key, and nothing but the key. If nothing else, take that, write it on a piece of paper and stick it on the wall in front of you or on your divider, cubicle divider or whatever it is, because that is the trick to normalizing a database, is to fit your data into that statement. The key, the whole key, and nothing but the key. And really, I cannot stress enough, this is where it all begins. Now, I know a lot of people have applied this philosophy instinctively. A lot of programmers apply this whole philosophy very instinctively. So it may not be a major problem, but it has to be investigated and has to be recognized as a significant checkpoint, shall we say, in the roadmap of modernization. You have to know what you're getting into here. Because if you don't, and if you don't look at it carefully and consider the impact of this, you are going to go down the wrong road. Come back to Alvin Toffler, who says that you've got to have a very good idea of the big picture before you start building your little smaller pieces, so that the smaller pieces all go in the right direction to complete the big picture, or words to that effect. And the number one process is normalization. And it's probably only after you've gone quite a long way down this road of normalization that you will begin to understand how much simpler this begins to make your life. Once the data is organized in a normalized manner, things become easier. Databases are not dynamic anymore. And that's the biggest problem of application, modification, enhancement, and addition, is the fact, the terrifying thought of having to go into the database and change files. Because you know that changing one or more files within your database, for whatever reason, is going to bounce around from program to program to program, and it becomes an enormous task. I will tell you that once you have normalized the database and you've stabilized the normalization to the degree that you're comfortable that it's all working for you, there will be very little need in future to change the database. And an example of that is the AO product itself. The AO product started development about 7 years ago. We built the database. It was a normalized database. And we added to that database all the things that even in the early days of the design, we felt were going to be necessary. 7 years later, or during the process of development up to now, we have had the need to change only one of the files in the AO database. There are 45 odd files in the AO database, and we've had the need to change only one. And that was because we made a mistake and we left out a field. And therefore the file was not normalized and we had to change it to normalize it about halfway through the development. All new information that gets added to the database gets added to the database as additional physical tables, normalized and related to various different files that already exist. So the tendency with a normalized database is to expand the database by adding files, not by changing files. And you do not, well, you probably can appreciate, but you won't really appreciate until it actually happens to you, how much simpler that process makes the maintenance, the development, the agility of your application. Because remember, anything that you add to the database affects nothing that already exists. Can't do. And therefore, everything that already exists doesn't need to be changed, doesn't need to be tested. Sorry, I'm harping a bit on this topic because it is of critical importance. And now, it is time that I actually popped your bubble, because third normal form is theoretical. I have been a developer of application systems as well as databases for most of my career, and I realized very early on in the process of building applications and databases that there are some things in a set of data that are better repeated. Because if you consider third normal form and its dependencies on a key, you are removing all the redundancy in the database, i.e. no field of data is ever duplicated. It's dependent on a key in one file, and therefore it cannot exist in another file because it's dependent on a key in file 1 and can't exist in file 2. So all the redundancy, the duplication of data is removed in a normalized database. But I also realized early on that doing that can, in the practical area of writing application code that is efficient and flexible, some fields need and bear repeating in the database. And I will use AO again as an example. There is AO, as you know, or if you don't, I'll tell you, is a tool that manages the database definitions, i.e. it contains the entire definition of the database and its structures, and it controls how those structures are processed, created, compiled, managed, and related together, etc., etc. And it handles, at the present moment, it handles 7 different file types. Well, 8 different file types. It handles the 2 types of physical file, that is a DDS physical and a DDL physical, and then it handles the 6 logicals: encoded vector index, binary radix index, and SQL view, the DDS view, multi-file join, multi-format join, and or what they call non-join logical, and a join, a DDS join. Those 8 file types are identified by a single byte field within the database called file type. And all processing around AO is controlled by that file type. There is a file that defines the basic information about a data file, and that is where the file type is first defined, because it's one of the basic items of information about the file is its type. But what I've done is I have deliberately duplicated that file type through every single file in the 45 files in our database. so that I have access to that file type everywhere. I don't have to go and chain to another file. I don't have to join to the header file to get the type. I don't have to create an embedded SQL statement to find the type of the file in order to control the processing I'm doing. So what I'm doing here is I'm breaking the rules deliberately. And you will find that there will be instances when third normal form is a little too much. And so I tend to work at 2.98 normal form, which is where the practical meets the theoretical perfectly. There's some degree of duplication within the database is advantageous. So never let yourself be put or feel that you're breaking a rule and therefore you don't want to, you don't break it, and then you make the ongoing development much more difficult. So bear that in mind. You can break the rules, but as long as you are very aware of what you are doing. An example of what not to do is to have a transaction header and transaction detail file. The transaction detail is many records to one in the header. This is a true example. The header had a name, surname, initials, 4 lines of address, and another 4 lines of postal address. That was in the header of the transaction document. Every single line in that transaction document repeated the same information. Surname, first name, initials, 4 lines of postal address, 4 lines of physical address. Now that is redundancy of data that is wholly and totally unacceptable in a normalized database. So one has got to be careful to choose carefully the rules you're going to break, and you have to justify them, not only to yourself, but the other people who work around you. Okay, that is it. The key, the whole key, and nothing but the key, is the rhythm, the mantra of normalization. I thought I'd squeezed the theory down to a very good, very nice phrase. I'd like you to learn it, to repeat it to yourself over and over again. And every time you look at a file, let that run through the back of your mind and look at the file in that context. That will tell you very quickly whether you are looking at a third normal form file or not. One last thing before we move on. I'm going to leave this up so it burns itself into your mind. I've now forgotten what I was going to say. Never mind. Not serious, we can proceed. If it's not on a form, it's not a foil, it's not important. Okay, let's move on. This is a question page. Are there any questions? I know this is a massive topic. Okay. I have a question from Kay. If you have a table that has multiple dates, but they are unique in themselves, i.e. invoice date, past due date, entry date, etc., must these be in separate tables to be third normal form? The answer to that is no. And in fact, the next topic that we're going to discuss has got a heavy emphasis on exactly this. These are data attributes or data elements or fields or whatever your particular flavor of expression requires. An invoice date and a past due date, as long as they are dependent they are both dependent on the key of that file and only dependent on the key of that file. They can exist. They are not duplicate elements because they have different meaning. And that is essentially where you look at. I will pick this up again in the next few minutes because we're going to start looking at another component of the data dictionary. We have some programmers that want to code in extra fields for future unknown use. What are your thoughts on this? Where do you draw the line on this one? How many fields and what attributes? Extra fields have no meaning. You don't know what they're going to contain. And shall I tell you from my 40-odd years of experience with it, no matter how clever you are, you put in extra fields and they won't be the correct definition for the one you want. What I do in all my files to give myself some simple way of avoiding making changes to files is I always put into a file a field called a record status, even though I don't use it in a lot of cases. It's usually between 2 to 5 bytes, depending on the type of business you're working in. And it's generally not used for anything, but in some cases, it could be used to indicate the status of an order or the validity of a transaction or something that's either active or inactive. That type of field with a couple of extra bytes that you can use for different purposes is acceptable. If you have or want to add half a dozen fields, you want one of 10-byte alpha, you want one of 5 numeric, you want another one of packed decimal, 5 with 2 decimals, etc., and you stick them at the bottom, the chances are that 99.9% of the time, whatever you put in them probably will violate the normalization rules, and you will cram them in there because there's a space and you won't have to, well, of course, you will have to recompile the program because whatever program is going to need to use those fields is going to have to be recompiled anyway. And so they are generally going to end up being more confusing than of benefit. And particularly if your database is properly normalized, you will find that extra fields that are going to be used in the future will be for a particular integrated purpose and will actually slide into the database as an additional file without any problems whatsoever. So instead of putting fields into files in case I'm going to need them, spend that time and that effort normalizing those files properly, and you'll find that your extra fields can be added to the database with an additional file, which makes life very much easier because you have to change nothing except what needs to use the new elements. And there's one thing, based on this question, that I must say to all of you. Please, if you have a need to add a field to a file, do not never ever look at your database and say, oh, this file has got a field we never use. It's called width. But let's use it because it's got 5 decimals or 5 things before the decimal and 2 after. Let's use it to hold the value of this transaction because width was put in there. We thought we would use it, we didn't, so now we're going to put the total value in. People who get caught doing that should really be strung up by their toes, because what you are doing is you are creating a field in a file that has a completely misleading meaning, and is guaranteed to turn around and bite you at some time in the future. The whole idea behind what we're talking about as a roadmap, and when we get down to other elements of the I/O servers and so on, we're trying to decouple the database from the application. We're trying to separate, tear them apart, so that when you think of the database, you only think of the database. And when you think of your applications, you only think of your applications. And when your application developer suddenly realizes that his specification that he's got to develop a new component within the system requires a whole bunch of extra data elements which at the present moment don't exist in the database, that developer must go to the database administrator or the database engineer or the database architect. And they must sit and discuss these additional elements that need to be added to the database. And the database engineer, architect, specialist, whatever name you want to give that person, he is the person who is responsible for establishing those new elements within the database and placing them in the appropriate places, regardless of what the application is going to do. He has to put those new requirements into the database, considering only the requirements of the database. Then once that's done, the developer can then get on and begin to develop his application. Previous organization I worked for, there was only me and my number 2 in command who were allowed to make physical changes to the database structure. No programmers could touch the database in any way. And this is something you must begin to understand about the separation of responsibility. The database exists separate from the application in a modernized environment. And it's very important to try and keep that separation of duties very clear. Because if you don't, you are going to find that you progress in a divergent manner. They're not parallel lines, they're not even converging as is required by Alvin Toffler. All the small pieces have got to go in the same direction. That's not going to happen if you don't have autonomy in the development of your database. And all your little pieces are going to gradually head off in different directions, and you're going to end up with a bigger mess than you started with. So, again, I come back to this business of identifying a person or persons, it's preferably 2 persons at least, who will be responsible for the definition and construction and management and maintenance of the database. And it's so important for people who are going to start this process to realize that the database and the application are going to become 2 completely separate, independent elements. Yeah, I've harped on that one pretty much, haven't I? And I'm probably going to be doing it again later on because it's very important. So, before we move on, are there any further questions? I've given you my email address, so if you feel like later on when you've had a thought about this and a question comes to mind, please drop me an email. If you're looking through the recording maybe and something comes to mind, drop me an email. because in that way I can build that into the subsequent conversations. Storm seems to be over at this end. It's quietening down, so it looks like we're going to make a full session, for which I'm truly grateful. Right, let's move on. Where's my little button? Click. Thing called a data dictionary. A normalized relational database is made up of a thing called, or obtains its data elements from a thing called a data dictionary. Now, a data dictionary, or metadata repository as defined in the IBM Dictionary of Computing, is a centralized repository of information about data such as meaning, relationships to other data, origin, usage, and format. I need to add to there short descriptions, long descriptions, and we are going to expand AO to handle things like font, color, etc., etc., etc. A data dictionary is many things to many people. Some of us who go back a long way recognize it as a field reference file. And others had other ways of defining the elements that were going to make up the database, because it is from this dictionary that we gather the fields that we then define within the database. Now, obviously, if you have a database and no dictionary, you have to also be able to work backwards. And AO has that functionality of being able to take your existing schema and from it build a centralized repository of information about data. Metadata repository, we refer to it as a data dictionary. It is the single place where the definitions of all your individual data elements are stored and controlled. And I must stress now that whoever is going to be given the responsibility in your organization of looking after the database, remember what I said, that this database architect, database engineer, or database administrator, whatever you want to call that person, it's not a full-time job. In the beginning, you're going to be very busy. There's no question about it. But once the dust has settled and the normalization is relatively complete, it's not a full-time job. But it is here from the dictionary that everything begins. If you wish to create a new file which contains new elements that the company has never used before, the first place they get deposited is they get defined within the data dictionary. And of course, first checking that there isn't already a field in the data dictionary which actually satisfies those particular requirements. i.e., you only want one definition in the data dictionary for every business data element. And here one has to be very careful about how you define a data element. A data element or data attribute is defined in terms of the business. It is defined in terms of how the business is going to use that information, what that data element means to the business. It does not include the file as a frame of reference, And it certainly does not include the code, the programs, the application as a frame of reference. Elements that are built into the data dictionary are purely and simply defined by the business need. What does the business want? I use an example. An invoice total is a distinct business data element. An invoice total means something. It is the total on an invoice. It has a name, it has a description, it has a size, it has everything, and there is only one of them. Now, I'm going to ask one of the people who's doing this for the second time around. We had this discussion, and the question I always ask potential customers is, how many distinct data elements do you believe that you have in your data dictionary? Sorry, in your database. How many distinct data elements do you think you've got in your database? Now, in general, I usually get answers of around anywhere between 3,000 and 7,000 different data elements. That's pretty much, on average, what I get. We have a tool which you are most welcome to download and use. It's called AO Inspector. And one of its bits of information is simply it analyzes the dictionary, the database, and actually tells you how many actually distinct data elements it found in the database. And shocking as it may seem, nobody I've ever asked this question of has come close. Their estimates have not been within 1/10 of the actual number of data elements that there are in the database. There are a lot of duplicates. Those came from the old 38 days where we used to prefix data elements because it was difficult if you had two files with the same field in it. You didn't have a way of renaming it, and it was very difficult and complicated. So we used to call this file AA something and this file BB something, and then we didn't have to rename them, and it was much easier. In those days, 30 years ago, please believe me when I say that that particular practice of prefixing fields in your database files will give you so much pain in a modernized application development environment. And as soon as you want to start doing things like big data and data analytics and all of those types of wonderful things, if you have more than one name for one element, you're not going to be able to benefit from these amazing developments that are occurring within this particular industry. Because no matter how or which way you cut it, data analytics doesn't work if you have 75 definitions for the same data item. It does not work. And I am now going to try and find I seem to have a small problem here. I'm going to let me move on to the benefit of the data dictionary first, and then I'll see in the meantime if I can get my green screen up. Where is it? There we are. Okay. I didn't plan for this. Benefits: a consistent naming and definition for every item of business data. Now, you can have the same data element in every single set of files. I have one or two in my 45 files in my database. System name and library name. These occupy the first two positions in every single field that I have, every single file that I have in the database. They're defined in the same way, they're spelled the same way, they have exactly the same attributes. They're actually defined in the dictionary. And because of some of the modern capabilities that have been given to us within the RPG development framework, such as prefixing or qualifying, the fact that the same name exists in two different data files makes it is no handicap at all. In fact, it's a huge advantage because I can move 20 fields from one database file into another database file with one statement. I don't have to move 20 different fields. I can move using one statement, I can move 20 fields across as long as they have the same name and the same definition. So it's of huge benefit in the development and the number of lines of code. This facilitates data-centric systems development because you're looking at data elements that are business-related and not data elements that happen to be related to this program or that file or something else. You have a very data-centric view of the database and thereby a data-centric view of the systems that you're busy developing. It helps, as I've mentioned, with data analytics because one single field defines that data element across the entire database. It also makes it much easier to analyze your database, look for commonalities, and so on and so forth. Cognitive computing, aka rule-based systems. Watson and AI techniques. Now, you guys may not at this stage even be considering cognitive computing or the Watson AI type techniques. And probably the reason that you can't even consider it at this point in time is simply because you haven't got a tight enough handle on your database and your data definitions and your data dictionary. Now, AO provides a data dictionary management facility and also a facility to load that dictionary from your existing database and to rationalize it. And eventually, in time, reverse engineer the fields that are duplicates and replace them in the database files to begin to create a standard element definition. Now, I say eventually, because although we can collect the duplicates, we can create what we refer to as a master definition, and we can associate dependent definitions to that master. And all future files can use the master definition. The historical files will still use the assorted definitions. And that may continue for some time because to reverse build the master over the top of alternative definitions is going to change names. It could change attributes. It certainly could do a lot of things which will require changes to application code and projects to build and change things, which we all know requires resources, and there's never any time to do that because there's much more important things to do. So it may be that one takes a line in the sand at a point in time and moves forward in a modernized way, in a data-centric manner, and leaves the historical stuff to be taken care of by another motto of mine. The best way to gain ground in a modernization process, particularly when you are pushed for time, you're not being given time by the powers that be to spend time with modernization, the best solution to this problem is to use the motto, if you touch it, you fix it. Which means that every time you have to touch a file for any reason required by business, you fix it in line with the modernization paradigms. It's like the old sign in the shop window that says if you break it, you buy it. In this case, if you touch it, you fix it, is a good motto, again, to engrave in your consciousness. And gradually over time, this can guide you and clean up some of the historical stuff. Be aware definitely that a lot of the historical stuff is never ever going to be modernized. That history file that keeps 7 years worth of transactions in case I need to look up something may never be modernized. This bunch of files that's only used by my year-end systems may never be modernized. So you have to make a choice as to what you are going to modernize, and obviously we apply here the 80-20 rule again. A 20% of your database is responsible for 80% of your business income. And it is that 20% of the database you need to target to modernize. The rest will come later, but you need to identify that 20% and you need to target that 20% because that contributes to 80% of your business. Okay. Now I'm going to just click onto this screen and you can think of some questions while I get a green screen up. No, I don't really want that one. I want this one. Okay. Any questions on the data dictionary before I actually show you the AO data dictionary itself? Okay, there's a question from Ed to everyone. Okay. F hot and W what? Ed, can you give me a slightly longer description of what those two fields are? Are they exactly the same thing? And if so, what? Hot or what? Original terminal. Okay. The OT is an original terminal. FH, I presume, is a prefix for file A, and WW is a prefix in file B. I'm going to make that assumption, which means that this is, in fact, the same data element. Now, remember that in our new definitions of a database, which is DDL, Data Definition Language, we have ways of defining long names. We call them long names. Everybody calls them long names. They're SQL names. And the maximum size of a SQL name is 256 characters. So instead of calling it FHOT, you could call it the original airport terminal identification code. We also have the short name, which is the internal system name. I'm going to open the data dictionary, and I'm going to open a data dictionary that, right. This is AO's data dictionary. It is loaded from the schemas. All right. It's loaded from the schemas as they are imported into AO, because you load AO and then you import your schemas, and during that import process the dictionary is also imported. And an imported element in the dictionary will be what? By the way, just so that you understand that this is in fact a sort of a green screen. The reason we chose, originally when we launched this, when we launched AO, we provided it with two faces. We provided it with a conventional green screen face, and then we provided it also with a graphical user interface. And we found that actually everybody preferred the green screen because it's what they've been used to for 100 years. I would like to see, just by an unmute, if you wouldn't mind, how many of you prefer to work on the green screen? Yeah. Okay, not as many as I expected, unless of course there's some people that have fallen asleep. But a lot of people who've come up in this industry over the years are just so comfortable with the green screen that in fact the graphical interface we provided was never used, and so we fell away. What we did halfway through our evolution is we created a half and half green screen. This screen, as you will see, is similar in a lot of aspects to the conventional operating system green screen, except it has some unique variations. It has no options column. It is cursor sensitive and it is click sensitive. So if I go to this first one, put my cursor on it, and right click, I actually open a context sensitive menu. I can double click on function keys. I can also double click on an entry and it will open the context sensitive menu. Now I'm using the iNavigator. the navigator for IBM, I don't know what they call it, the emulator from there, which allows me to customize my mouse to act as an enter key, and I can get all of these functionalities. If I want to add a new element, I double click on the heading and I get an entry element. So although the screen is green and white and blue, which are the only colors that I have available, it actually is halfway towards operating as a cursor-sensitive mouse-driven screen. Most of the functions, including its help text and its extended help, can be driven from the mouse, but of course, as soon as you go into the help screen and extended help, you've then got to do the conventional keyboard page up and page down, because now we're in the operating system and not in AO's interface. So what we've done with AO is we've kept the green screen. One of the main reasons is because it's built using a tool called UIM, User Interface Manager. And that is the same tool that IBM has used to build the operating system. As a result, we are using the same tool, so it's very compatible with the operating system, but we have added extra functionality to it to sort of be a halfway solution between a green screen and a point-and-click graphical user interface. The only thing we can't do is pretty pictures. We have 3 colors at our disposal: white, green, and blue. And so in each help panel, it will explain to you what these are. This is a dictionary. We were told when we asked the customer, I think it was a figure of about 7,000, they thought was their total number of elements in their data in their database. When we actually installed the product and did the full import, the total number turned out to be 75,000 different data elements. And they're all here. You can see by using alternate views, there is an option to put in an alias or a SQL name. That is a long name. Now, AO has not allowed the full use of the 256 characters, because that is not a data name, that is an epistle. 256 characters, to my mind, is over the top completely. So we have limited the long names to 50 characters. If any of you have any objections to that, well, then send them to me and I will make necessary adjustments if I feel it's necessary. But 50 characters for a data name is a long data name. And you can be very descriptive about the data element. But it is always tied, and you define the data element using the short form internal system name of the data element. You can provide an alias or a SQL long name. You can provide that name for both DDS and DDL files. And you can, if you wish, switch on a new indicator in RPG, which makes the long names available to code with. Me, I'm an old-fashioned coder, and I use the short field names, and the shorter the better. But the long name is always a very desired thing for the people who are familiar with the SQL paradigm, the SQL client type thing, where they can look up fields by long names and they get a better idea of what they are. They're not working with them all the time, whereas developers do, so you tend to get so used to the short names. But you can see very clearly that that is a prefix, AC. And so a lot of the duplications come from prefixes and that sort of thing. Digits, bytes, number of decimals, allow, null, var indicator, allocate length, only of course if you use it with a var. The actual text description, and I would like to know how many of you actually use the text description or leave them blank. And then we have a unique dictionary reference ID for every single element that is installed in the dictionary. It contains default values. There's an indicator here that is the master reference. A star indicates that it is a newly imported element, hasn't been assigned yet to either master or dependent. And then, of course, we have the column headings and a category, a class, category, and group, which have been added. Here they are down the bottom. They are free-form, user-defined fields that will allow you to categorize, group, and class your data elements in your dictionary to suit yourselves. They are just added in there to give you easy groupings for filtering purposes. Because the dictionary does have a filter. It's like all the panels in AO. The filter allows you to select anything from here. So I can pick all fields that begin AC, and I will get only the AC fields in the dictionary. So the filter allows you to obviously work with sets of your data dictionary. A couple of other features is that this green one has been assigned as a master. And the sequence 1 and 2 here indicate that these two are duplicates of that, as you can see by the names. Now, if you go across, there's the difference. There's one difference in terms of the defaults. That actually was a bug a little while ago. This is no default, comes from a logical file. It's now been corrected. So these are duplicates, and the blue indicates that they are dependents, i.e. they've been assigned to the master. And you can work through, if you double click on a white one like this, you can set it as a master, which makes it green, and it says master field up there. Now you can go about, this is an address, so you can go about assigning other fields. You can link that to the master, and it will go blue. It's now linked to this master. If you want to, you can display related elements, and it will only show you the elements that are related. So this is the way you rationalize your data dictionary within AO. You pick or create a master version of a data element. You can create a new data element that you want as a master if there's nothing suitable. And then you start associating elements that have the same definitions and mean the same thing. They might have different descriptions, they might have different attributes, they might even have different data names. And believe me, when you start this job, this is the job. One of the jobs that you have to begin with from the beginning. I think it was either in the first session that Nathan asked me, where do you begin? What do you actually start to do? One of the jobs you need to start to do right from the very beginning is you need to start rationalizing, or what we call sanitizing, your data dictionary. I.e., you need to pick out what are going to be masters and what are going to be dependents, and you need to identify them and begin defining them within the data dictionary correctly so that you're getting a handle on your data definitions. I can clear the master out of there. And the interesting part about this is this is a job that somebody who knows the database and who knows the system, and generally will be the person who is likely to end up being designated, if not already so, designated as the database engineer, database designer, or administrator. You will use a thing like a filter, and you will put as a text description, you will put the word address in there, and you will pick up everything that has the word address in its description. And as you can see, there are many. This is the one I use because I always get a super duper large number of hits on this one. Now I'm going to ask a question, and I would like you to think about it, and I would honestly like somebody to try and answer the question. Ship from address 1, let's pick this one. Ship from address 1 to ship from address 5. As opposed to ship to address 1, ship to address 5. Is this, the one that I got the box around, is that 5 data elements or 1 data element? This is possibly the hardest job to get right. It's common sense, it's logic, as long as you focus your mind on what you are trying to do. You are trying to define a business element that's specific to the business. Generally speaking, Matt, yes, they will be in the same file, and they will usually be 5 lines of address. Yeah. I see nobody's going to stick out their neck on this one. Right, I'm going to. But please, I want to hear... Dean, thank you. 5 data elements. Why? Why are they 5 data elements? Is address line 1 essentially a different business element from address line 5? And the test for that is quite simple. Do you always fill in all 5? Okay. Another answer here, we set up ours as address 1 and 2, then name, city, street, and zip are separate fields. And that gives you a clue as to what we're talking about here. Address, a line of address, 60 characters long. All right, that's longer than I'm used to, but in America it's a big place, so maybe your address lines are long. But a line of address is actually only a single data element. Ship to address 1 and ship to address 2 are not different data elements. They are lines They are address lines. You can have 1, you can have 2, you can have 6, you can have 5. So, but they are lines of address. They are data elements that are broken up into, in this case, 60 characters that are part of a address. And therefore, an address line is a single data item. Because as we get from K, they use only address line 1 and 2. And then they specifically ask for name, city, street, and zip code. Because they are very specific about what they want in their lines of address. And why do they do that? It's quite obvious. Because they can then use those specific data items to group, consolidate. They can analyze their data because they know that there's a city. They can pick up the city. So they have chosen to actually give an address names and allowed for 2 fields, which are, I would imagine, building, street number, street, and something or other else. But the actual address is a single data element. That there. However, that ship from address is different to ship to address, because from a business perspective, and this is where I get very intense, shall we say. Ship to address is not the same data element as ship from address from a business perspective. And once you begin to see this, again, material issuer address. This one is weird because we've got, you see what's happened here? We've got 5 of them, but 2 of them have a different description to the other 3. Actually, those are all one element. It's the material issuer address line. Remember that when we put that field, material issuer address line, when we put that into a file, we can rename it as 1, 2, 3, 4, 5, however many we need. So within the file, you might have 5 lines. You might make provision for 5 lines of address. But in your data dictionary, that is only one element. Let's look at something else. If I can find one here. QUA, quantity. This is a great one. Quantity, quantity, quantity. 3 quantities, 1 at 9.0 and 2 at 11.0. Here you can see one is BI quantity, BIV quantity, and BLL quantity. So those 3 are not duplicated because they have different names. But what are they? What do they mean? Let's have a look and see whether there's any additional description on them. No. So there are 3 elements in this database. Nobody has a clue as to what they are. Is one of these the same as that one? i.e. is exploded quantity and quantity the same? We can also look at max quantity. Is exploded quantity and exploded quantity shipped the same data item or not? This is where the building and the rationalization of the data dictionary becomes pretty difficult. You've got to know your industry. you have to know your applications, and you have to know your database, and you have to know the business. And very often I recommend that when you're looking at data dictionaries and database definitions, you include, you can almost form a committee, and you include as part of that committee people from not the IT side, but from the business division side to help, to advise. Unless, of course, you have somebody in your IT department who's been there since the company started and knows everything. Then, of course, that person can be a good go-to person. But one has to decide what actually these are. Now, if I looked at these offhand, I would say these are within the database and within the business orientation. I would take a guess that they were actually two different elements. And the reason I would do that is because they actually have different attributes. One is 9 bytes numeric and the other 7 bytes numeric. But now, is that true or is it not true? Because you need to be sure. Because I have two different data names here. And I want to be able, first of all, to give them a new name. I want to give them a nice long name. But I have to be sure that these are, in fact, different elements and not the same element, but defined over years in two different ways. So, invoice quantity. Invoice quantity, here is even, invoice quantity to my mind is definitely a unique element, particularly when you juxtaposition it to order quantity. Order quantity and invoice quantity are not the same data element because they have a different meaning within the business. I keep harping on this. I keep pushing this one because this is what, when you're working with a data dictionary and you're setting up the base for your future data usage, you have to think about it from a business perspective. And therefore, invoice quantity and order quantity are different elements. But in this particular case, we've got something very strange. We've got an order quantity which has 90, and we have an invoice quantity of 90. We have an invoice quantity of 80 numeric, and we have an order quantity of 80. And in fact, this field here those three fields have the same data name. And yet the description indicates that this is the original quantity ordered, and this is something else other than the original quantity ordered. Now, I could go on like this all day, because the data dictionary is something you will find, and I would suggest if you really are wanting to come to grips with this, take our inspector, download it from the website, install it. It's free of charge, you don't even need a license. And just run it over your main database schemas / libraries. And have a look and see how many data elements it shows up. It doesn't give you the dictionary, you can't work with it, but it will tell you the number of different data elements that you have in your dictionary. And I think you'll be surprised to see what a vast array of data elements that you've got, some duplicated by data name and others duplicated by description. I mean, this is quantity. You can see how many quantities there are. Minimum order quantity, minimum release quantity. These are definitely different. but there's something different about them because they appear, a number in the sequence indicates that these two are duplicates, and there's something different between them, and they've come from two different files. We do, by the way, have a where used option, which can actually tell you where these files are used. The white shows the files, tables that are using the field name you actually clicked on, and the green ones show the files that are using the duplicates, whatever they might be. So we can then also use you will see some of the screens still have the option column on them, and you can actually look at the columns in that file, and you can see exactly where that field is used. So the dictionary gives you a lot of power in terms of identifying a master and then associating various fields that are in use with it so that you're getting them consolidated and rationalized. And it's a task that you need to do to come to grips with the database, the data elements that make up your database. Now, I can see very clearly this FP is probably a prefix. There are a couple of tools that are available in the dictionary that will help you. You can analyze prefixes and you can work with prefixes. I don't know whether this one's been, yeah. This one has worked with prefixes, and you can see what files. The field count in that file is 154, and 100% of them have a prefix. And you can see it shows it up. Every field in that file has an MB as a prefix. So its actual data name has been split out. Now, you have the ability to select, to drop what you've selected, and then you can process what is left, what you've selected. And what will happen is it will generate a master without the prefix, and it will automatically associate the prefixed. Everything it finds with an RDAT on it, it will associate with the master RDAT, which it's then generated. So it does do a chunk of work for you in terms of manipulating prefixes and suffixes, which are at this stage in legacy systems probably the heaviest job, is to get rid of those. And you can see that the field count shows you how many fields there are in the file, and the percentage shows you how many of those fields have the same first two letters or three letters, whichever you've chosen to work with. And so all of these are 100% prefixed. And you can go through the whole lot, and you can turn them all into masters, and then you can begin to rationalize your dictionary that way by removing the prefixes. You also have some packages or other people have used suffixes. This one doesn't. But other packages and people have used suffixes. They put numeric suffixes on the end of the field. And so we offer the similar analyze and work with to try and take off the suffixes and make them, get rid of them. Because that's the number one exercise. Getting rid of your prefixes and suffixes and rationalizing, and then choosing a proper name for the short name as the master and the long name as the master. Then what you can do is you can then add that long name to your existing data file definitions. So very quickly, you could give your database the look and feel of a SQL database by having long names, which is what would satisfy your SQL clients, because now they can see the long name instead of what they think is old and archaic 6 to 10 character data names that they don't understand. But this one is heavy lifting to get your dictionary in order. And I'm sure there are a couple of people listening to me now who would agree that it is heavy lifting, but needs to be done in order to rationalize your dictionary, because that is the thing you're going to use to build your database going forward. You also want to connect the existing database to the new fields you're using going forward. Because, and this is important to understand, the AO database is available to any user of AO. The information that we store in our database that relates this field to that as a master, to this field as a dependent, and to this long name and to that long name, you guys can use those for your own purposes. That information is available because AO has consolidated it, and you can use it for whatever purposes you like. You can use it for documentation. You can use it for, I don't know, choosing fields, whatever. And you can run SQL over the AO database. You can put your own logical files over the AO database. There's only one rule, is that you don't change the contents of the AO database. Otherwise, we can't help you. But the data is collected. It's all arranged and organized, so it is available for whatever you like to use it for. Okay, so are there any questions about a dictionary? There are probably 1,000 questions. Please put them through to public so that I don't have to read them out again. Everyone, just put them through to everyone if you have a question about the dictionary. It's probably the toughest job in the whole modernization stable, is to make these decisions about what is a genuine dictionary element that is business specific and what are duplicates of that, whether they're actually defined differently. One particular system I worked on had a number in a master file. The master file had 68 records in it, and the key of that file was actually the number of a supplier of services, and there were only 68 of them in the entire country. When rationalizing the dictionary, I found 19 different definitions for exactly the same field. There were only 69 records in the master file, and yet I found 19 different definitions. And those definitions, those 19 different definitions, did not include the descriptions, the different descriptions. Because remember, a description is seen as a difference. But the differences were in the name, whether they were alpha or numeric, packed or decimal, the lengths, which ranged from 5 packed numeric to 35 alphabetic. There were 19 completely different definitions with different names, some of them, for exactly the same data element. So there was no ways in that environment that you could correlate through the database and pick up that particular master code. It just couldn't be done. But you can use AO's database to help you do that if you need to. But in this particular case, there were 19 different ones. And of course, they had evolved over many years. And I'm going to admit something, which is probably the last thing I'm going to say this evening, because we're moving on to a brand new topic, which I would rather not start on this time at this stage, is even within AO, which has been built from the ground up with all these modernization principles in mind, there are still some data elements that are the same element with a different name, i.e. a duplicate. Fortunately, there are not many, but there are some. So that shows you it's not the easiest thing in the world to avoid. And over 30-odd years of development by an assortment of different people with different skill levels and different understanding of the business, and particularly because historically the developers themselves were responsible for the database. It would not surprise me if you found in your databases a huge number of duplicates. I hope you don't, because that is a job that needs doing. You need to rationalize and sanitize your data dictionary as a matter of priority, and you will find, I promise, because I've been there, done that, that once you have got a consistent set of data element names within your data dictionary and start rolling them out into the new database, you will see how much simpler and easier it is to understand from a development perspective what you're dealing with. Because the naming is absolutely consistent. Doesn't matter what file you're looking at. If you see a name that you recognize, you know that it's that name. I have a name called SYSNME, system name. I still haven't broken my habit of 6-character data names. Probably never will. SYSNME, system name. That exists in every single file in my database, but when I see it, I know exactly what it is. It has the same attributes, the same description, and does the same thing. And that is so much of a benefit. Unfortunately, I've always had a problem, because this is something that I can't prove to you unless you do it. You will, if you do it and do it well, you will come back to me and say, wow, this was a great thing to do. And all I can do up front is to promise you that you will come back to me and tell me that this was the greatest thing you ever did. Matthew, Dimitri, to everyone. Okay, Dimitri, is there an AO tutorial that shows step by step how the product is used throughout a typical modernization project? That is being worked on. We have some scenarios, some documentation, yes. We are quite prepared to run tutorials via WebEx through specific scenario developments for those people who are working with these projects, until we have developed something that is actually available either as a Vimeo type thing, or some sort of thing you can get from the web. But we are trying to build it. Documentation, I find writing code a lot easier than writing documentation, but we are trying. Matt, I've been doing MS SQL for 10 years and still have trouble using more descriptive field names. Is that in response to my comment about the fact that I'm still stuck on my 6-character data names? I thought so. Yeah, I'm afraid old dog, new tricks. there are some new tricks we need to learn, and we have to learn, like a certain amount of SQL and standardizing data dictionaries and that sort of thing. These are tricks we have to learn because they are of benefit to everybody and to us going forward. But there are one or two that are very hard, and I can't get rid of I have a set of abbreviations for 6-character data names, which has been with me for 40 years, and I'm almost impossible to shake it. So the important thing, I think, here is we cannot, because of a completely varied audience, shall we say, in terms of systems, there is no one solution for every single person, for every single application, for every single dictionary, for every single anything. No silver bullet. So the best we can do is to give you a clear idea of where you need to focus and how you need to go about it. But remember always, and I'll finish with this, remember always that the primary and most information about your system is in your heads. And yes, we can provide the tools. Yes, we do provide the guidance, the support, all sorts of things to help. But we cannot be expected to understand your system in sufficient detail to do it as a consultant, shall we say. We have a roadmap, we have a methodology, but of course it varies, and we can help with the variations. Yeah. Nobody can know your system as well as you do. And nobody can make or modernize your database as well as you can. If you're given the tools and the methodologies, you can do a better job than anybody else in the business. And if people say they can do a modernization job for you on your database without spending months and months and months and months understanding your database, then I would be very wary, because it means you're going to get a modernization job that is not going to solve your problem. So I leave it at that. Thank you very much. It's been a heavy session. But it is a core principle that we've been through today. The normalization and the data dictionary are core principles of modernization. Without them, you ain't going anywhere. So please feel free to send me any questions if you want to, so that I can pick them up and clarify them as soon as possible, because this is definitely the basis of what is coming now. Okay. Thank you very much, everybody. I had fun. I hope you did. And we will see you, what's today? Tuesday. We will see you on Thursday. Have a great day. Thanks a lot.